So as people are wandering in, I just wanted to get an idea of the room. How many people were at the very first session for the AI pathway, AI for everyone? Oh my, lots of you. Okay. Some of this content will be repeated just at the beginning to get us all up to speed. For those that didn't attend, curse you. I mean, shame on you. How many DBAs are in the room? Oh, lots of you, good. I guess it helps having DBA in the name of your session to be able to get the target audience correct. I guess that helps. That's good. Any data scientists in the room? Okay, out. No, I'm just kidding. Oh no, is that Anna? Oh, I was just talking about you. Josh said, is this going to be a class where I'm going to be able to keep up, unlike Anna's? I said, no, I'm not nearly as smart as she is. So everybody turn and look at Anna. No, I'm just kidding. Anna does the other session on the AI pathway, and she's absolutely brilliant and a really great speaker. So we're lucky to have her in the room. So we're going to get started on AI for the DBA. So this is a session for the DBA specifically, because we're going to talk about the things that are important to you as a DBA when it comes to AI. The obligatory, please silence your cell phones. That's to remind you that as a speaker, I have the right to answer your phone if it rings during my session. You're lucky that I'm polite as a Canadian, and I won't say anything rude, but you know, it's a good opportunity to remind you just to turn off the cell phones. The session is being recorded, so it's also excellent for the session recording if no cell phones are going off. I just want to remind you that PASS is a very large organization. There is a vote going on, so you do have an opportunity at this point in time to vote during the election. Vote for Melanie. Who is Melanie? This is not a plug for me. There are 6 amazing candidates running, and all of them are very good. I will leave it at that. But it is an opportunity to have a say in what happens in the community and what we are doing as a community moving forward. This is a large community. I think of it as my SQL family. I'm sure you've seen or heard of the hashtag SQL family. It really is. It's the most inclusive, diverse group that I've ever had the honor to be a part of. And I think that's really important. It lifts us all up, and it's important to lift as we rise, as it were. And that goes for all of us. So an opportunity for us to lift others up as we move on. One thing I will point out is somebody told me actually last night that there are 40% first-timers here. So I'm not going to call you out because people never like to raise their hand and point out that they're a first-timer. But if you are in the room and you are a first-timer, there are 2 hashtags that you need to be aware of on Twitter. One is hashtag SQL family. So if you need some sort of moral support or need to get in touch with people, that's a good one to use. If you have technical questions or issues, hashtag SQL help. And both of those are answered generally very quickly, usually faster than you can get support within your own company, which is often true. I've actually tested that out. I went to a new company. They had never been aware of the SQL family, but they were all SQL Server DPAs. There was 8 of us. And we came across a production issue that our Google foo was not good enough to get us an answer, and we were having difficulty with it. And so I challenged one of the other DBAs to see who could find the answer faster, either internally from other DBAs or through the internet, and I was done in less than 15 seconds. And it was the correct answer, not just any answer, and it was answered by an MCM who was a master at the time, and it was a fantastic answer, and it solved our issue. So I'm not going to promise any SLAs on that hashtag, but it's a good one to know regardless, particularly for DBAs because we have a huge, strong community of very, very knowledgeable, experienced DBAs that love to help out. So that's my plug for the community. Who am I and why am I here talking to you? I've been living, eating, breathing data for over 20 years now. I am a Microsoft MVP on the data platform. I'm a huge contributor to the community as much as I can, as often as I can. So I am a Canadian. So my enunciation may be a little bit different and your mileage may vary. I apologize for saying process when I should say process, or the other way around, because I can never remember and don't know which one is correct. But I will say those words and you'll have to try and understand them as best you can. I've written a couple of books highlighting women on the data platform, both technically and stories from the trenches. In the last couple of years, my third book for the third year in a row is coming out, and that's SQL Server 2019 Administration by Microsoft Press, called it's an inside out book. It's kind of a neat format where it gives you concepts of things that you might encounter that are not a part of the regular documentation. So it's an interesting format. So the learning pathway. This is something new that has come out at Summit. You may have seen a couple of slides that are similar to this. I did a session earlier in the week on AI for everyone, which some of you have attended. And the idea behind that is to give you a way to follow along and learn as you go. So if you knew absolutely nothing about AI, the idea is that was a nice little introduction. Then Anna had a great session that was a little bit of a deeper dive. And now we've split out into a couple of different personas as far as what you do as a profession. So this one is specifically for the DBA, so all of you DBAs are in the correct room. We're going to talk about DBA-related things. It may not be specific to you and what you do for your job, but it will be similar depending on your organization and what's expected of you in your job. Because as we know, not only is DBA default blame acceptor, but it's also a default dumping ground where you get to do everything quite often. So this is the room that we're in. If you're not in the right room, I want to respect your time and allow you to go to a different room or a different class. So what are we going to talk about? A little bit about the ecosystem, give you a bit of an overview, and talk about what's been going on in the ecosystem. We're going to look at who is who in the zoo, what are the different things that these buzzwords are that everybody is talking about, just so we get a little bit of a level set of what's going on. We will briefly cover, because I covered this in my last session, of the 5 questions that data science answers. So I just want you to have a little bit of an overview of what AI is, why it's important, and what we're talking about in general. And then I'm going to get a little bit deeper into some of the skills that are really important to DBAs for AI. So if you're one of those industries that's expecting a $240 million increase in the next year, in the next 4 years in your industry for going to AI, then these will be things that you're going to need to know for advancing your careers and moving your company to an AI company. Then at the very end, we're going to talk a bit about operationalizing models, because that's more often where the DBA comes in. So we'll talk about how do we operationalize models. We're going to start with something really basic, and I'm going to walk you through an example and why you want to do some of the steps that you do. We're not going to go super deep. I want to give you an idea of where you need to start your learning. So for a lot of people that I've given this session to, or similar sessions to this, there is a huge leap from where they know what they know now to where they want to be. So we're going to take that in steps. But this will give you a good overview and a flavor of all the different things that you might need to know. And you can each take a look at that and decide where you need to focus your energy in learning. So the ecosystem overview. I like to start with this because not everybody realizes where we've come from and how quickly we've made that leap. And it'll give you an idea of what kind of a leap you're going to have to make in your career from where you are now to where you're going to be going. So the enterprise in general is taking a real interest these days in adopting artificial intelligence. It can provide all sorts of return on investment as the number of companies implementing these technologies are growing very rapidly. There's been a 270% increase in the past 4 years alone. And that's not just in the development, but that's overall. So we're going to talk about the beginning, the current, and what that future is going to look like. I personally started talking about this journey back in 2016. When Microsoft first took took SQL Server as a product and started talking about it as an ecosystem or the data platform that we know today. So they started introducing back in 2016 Polybase. Has everybody here had a chance to use Polybase? Okay, has anybody used Polybase? Okay, so all right, so we did start at the right spot. Okay, that's a good sign. So the concept behind Polybase is the ability to take your SQL Server and connect, almost somewhat like a linked server, to other servers that are not necessarily relational databases. Okay? So if you've never heard the term Polybase, that's basically the concept behind it. And it was originally introduced in 2016, and DBAs were then able to combine data from systems other than just SQL Server. It was a little bit clunky, I won't lie to you. It was a little bit clunky, and Microsoft has been slowly building on that ever since. As well as changing from SQL Server to the data platform, we started moving away from on-premise to more SAN systems with private clouds. And now we're starting to move, then they started to move even then into hybrid clouds and the public cloud, Azure being the most prevalent public cloud. Keeping in mind that AWS has almost as many, is one of the largest purchasers of licenses of SQL Server ever, or anywhere. And that's something that many people don't know. So as much as most people actually do run it on Azure, AWS has a huge number of SQL Server instances. What we'll focus on today is the full Microsoft stack. In 2017, the marketing engine of Microsoft disappointed. They created this thing that they were calling Cortana Intelligence. One thing that you'll realize about Microsoft is they change names often. And I think that's because they'll try something, they'll realize it's maybe not working so well, and then they'll move on to something else. When I started talking about that in 2017, what the Cortana Intelligence was, people thought it was the menu bar for searching in the bottom left of your Windows 10 machine. It was not. It was a marketing fiasco, as far as I was concerned as a speaker, because it was really hard to convince people that it was something other than that. But the concept of it was really good, even though the naming was terrible. The idea behind taking our data, combining it with apps and other data sources or IoT devices, putting it all into a central location, and then using that to give us some sort of analytics, results, or information. That was basically the idea behind it, to take data, combine it with some intelligence, and it would spit out an action. So in hindsight, at the time, this was revolutionary. I don't know if you can remember back that far. It seems like forever ago, but it really was just a few years ago when Microsoft had this vision or idea, and they've expanded on it to the degree now that when we look back, it was like, oh yeah, of course, well that was obvious, even though it was revolutionary then. Today, that diagram looks very different, and this is only 2 years later. There's a lot of information here on some of the bots and the questions that can be answered. It incorporates things like security and governance, as well as text or voice-to-text, Q&A maker, a whole lot of different services. This is now an individual architecture. So before, when we had a very generic look of what the architecture looked like in terms of a concept, we now have very specific reference architectures for a lot of different things that we can do. So that kind of gives you an idea of how this system has grown. We've gone from individual ideas or 1 or 2 products to a whole slew of different things that can be done. So that takes us then to what I like to refer to as the art of the possible, and something I talk to a lot of people about in terms of what is possible. We talk about AI, and this is usually where I say AI, in the terms that we talk about it in technology and on the data platform right now, is actually, I would refer to it as a marketing term. And a lot of people don't understand the concept that AI as a marketing term versus AI as a technology that passes a Turing test. So there are tests that actually determine what is a true AI, and that is not necessarily what we're talking about today. We're talking about AI as a marketing term that allows us to do what I call amplified ingenuity. So I like to think of AI more as amplified ingenuity as opposed to true artificial intelligence. Just specifically when I talk to technical people, because we do make that distinction. We like to get into that nitty-gritty detail and understanding the differences. The idea with amplifying ingenuity is that it allows us to do things either faster, better, or more accurately. So we can form conclusions, possibly with imperfect data, or we can include text, voice, and images that we couldn't do before. Translations and automations, extrapolations, answering questions, things that maybe a human would need to do, such as a chatbot, but we could otherwise have an artificial intelligence do for us. That's what I would consider amplifying our ingenuity. So most people, I'm sure we've all had that starting out job when we first got into tech where we either had to answer simple questions or answer emails, that tier 1 support at whatever company that happens to be at. And that can be quite dull and boring. We don't necessarily want to do that all the time, and that's something that we can get an artificial intelligence to help us with, or in some companies take over almost entirely, or at least take on the first level of support. If you're as old as I am, you'll remember back to the days when we first had automated voice systems, and somebody other than an actual human answering the phone. Many, many years ago, that was revolutionary, and now we take it for granted. And that kind of gives you a bit of a concept of where this AI is going. Why is this important? Why do businesses care? Why do we as database administrators care? So there's a $120 billion growth in this industry expected by 2025. That's a lot of growth. If your company isn't already thinking about where it can be with AI or what it can do with AI to improve its processes or its systems, then it will be very soon. It's just the reality of the business that we work in. 84% of organizations feel it's a benefit to them to embrace AI and move forward with it. They're expecting it to increase productivity by 40%. That doesn't necessarily mean removing jobs. It could mean speeding up positions or things that we do regularly, or repetitive tasks that we don't necessarily want to do, or increasing productivity by not having to rewrite code, or by not having to do something over and over because a mistake has been made. So that productivity increase is not necessarily lost jobs. So how does that translate and help us as database administrators? So a lot of CEOs and higher up executives find that one of the things that's holding them back from actually investing in artificial intelligence is they don't think that their people are ready for it. They think that the integration of that is going to be difficult because the people who need to do it don't have the understanding, the knowledge, or the skills to do it. In the US, we're expecting at least 9% new jobs created by 2025. That's a lot of new jobs. And that doesn't include all the jobs that are going to change because of this innovation that's coming. So these are all important factors for you as professionals to understand and know what's going to change in your profession and what you can, and we'll talk about what you can do to improve that and make changes. So I talked a little bit about that ingenuity and how are we going to get those productivity increases? How are we going to become 40% all of a sudden more efficient because we've got some technology behind it? There's a lot of different things that we'll talk about that make up that, but what really is AI and why is it important? I like to refer to heuristics in that sense because it's important to know that as humans, we often don't think about all the different aspects of things that we're doing. We have a tendency to do things almost without thinking. I was chatting with a friend the other day, and we talked about how we got to the train station. And it's almost as though you either drive to work or you drive home and you don't even think about it. It just happens. But there's a lot of things, if you think about that, even just getting dressed in the morning, if you're going to go put on your socks, you're doing a lot of different actions that we don't individually think about every little action. We don't think about how you sit down to put on your socks or how you stretch the sock open to fit it over your foot. We don't think about those things, we just do them. And that is good to a large extent, but it makes us a little bit sloppy in that we'll take things for granted. So sometimes machines are better at doing that because how many of you have actually written code? Pretty much everybody. So when you write code, you realize that if you skip a step, suddenly something's not going to work. So if you are going to skip the step of actually stretching the sock out before you put it on your foot, it's not going to maybe work so well. So sometimes it's important to have all the different particular steps, and we can't just make assumptions, and we can't take for granted certain things. In my last session, I showed a picture that I had taken while I was on vacation. And I had showed this picture to many, many people, and loved this picture, was going to get it blown up because it was a picture of me and Captain Picard at a wax museum. And I was quite excited. I was going to have my hero on the wall in my office. And I used a bot that Microsoft had created that used facial recognition. And all of a sudden, after I had run this photo through the bot, I realized that there was actually 3 people in the photo, and I got photobombed. And I didn't like the photo anymore. It made me very, very sad. But it was a stark reminder to me how so often we take things for granted because we have biases and we don't necessarily do all the individual steps. If I had been a computer and was looking at it through my computer eyes, I definitely would have noticed that third person. And those are the mistakes that we can't make when it comes to maybe looking at an X-ray of cancer cells to determine if they've grown or not. We can't make those types of mistakes when it comes to people's lives. In a photo, it's just annoying and kind of funny, to be honest. But when it comes to science and people's lives, it's not so funny anymore. So it's important to remember why we're doing this and what the computer can do to make things better for us. We don't necessarily want to be jumping to conclusions. So a quick discussion of data science. And what are those 5 questions that data science answers for us? There's typically 5 different answers that you can get from data science. Now that might surprise you, that there's only 5, because we talk about AI for everything. So I'm not saying that you can only ask 5 questions. There's a lot of different science and algorithms that go into each one of these. They're more like categories, really. But when you're talking if you have to do any analysis before you start doing the AI in your company, depending on how broad your role as a DBA is, you may want to listen for keywords when you're talking to your employer or people in your company who want to implement AI about the problem that they're having and what they're trying to solve, and listen for some of the keywords of, I want to know if something is a yes or a no answer. Or the more common one that I hear a lot, because my vertical is typically often in banking and finances, I will hear, I want to predict the next best product. I probably hear that 3 times a day. Next best product. That's a common one that we all know from Amazon, because we always get reminded of what the next best book is that we want to read. Because I share an account with my teenage daughter, I think their data is a little off. She doesn't quite have the same taste in genre as I do, but it makes for some interesting recommendations. So they'll talk about how different things are organized. And that's another one that is a predictive analytics, so telling you what is going to happen or what's going to be next. Then there's the other categories that are also very common, and those are the words that you want to listen for. Is something odd, how much of something, or yes or no to an answer. Those types of predictions are less predictive, but can give you answers. So what are some of the skills that you're going to need as a DBA? And depending on the size of your organization, are there any lone DBAs in here? Yes, a few of you. So typically in smaller organizations, you often get asked to do a lot more than you would normally because it's a little bit more difficult to narrow down exactly what you do to just a DBA, depending on how large your organization is. So in some cases, you may wear more than one of these hats. And I purposely did this as a Venn diagram because there are a lot of different things in different sized companies that you have to do. Sometimes you have to be the sysadmin. When I was a DBA, if we had a large project going on, I would often have to help the sysadmins do building out servers, even though I was the DBA. But that was just the work that needed to be done. And sometimes you just have to do what has to get done. In other organizations, you may have a small shop of 2 or 3 people, and somebody who is a DBA doesn't want to do any AI, so you may get asked to do a little bit more on the data science side. It's conferences like PASS that allow us to get those skills to be able to do that, or to watch webinars. But we have to keep an open mind and know that we are going to be asked to do things that we wouldn't necessarily typically be asked to do, because what used to be SQL Server, which was quite narrow, has now become this ginormous environment of the data platform. And there's a lot to it now. So we have to be flexible in our skills if we're at a small shop, particularly. So what are those skills that you're going to need as a DBA? Almost always when you have to have multiple skills, and in organizations, regardless of what it is, there's always some form of communication. Communication is always at the forefront of all the different things that we need to do. So that's going to be number one. But some of the things that we don't necessarily know or that we haven't maybe encountered before would be some of the integrations. So when we're talking about combining different pieces of data and different types of data, there's a lot more integrations that come into play. And some of those are ones that you may or may not have seen before. So we'll talk about a couple of those and what they mean. And then notebooks. Is there anybody in this room who knows what a notebook is? A few people? Anybody use them? A few people, a little bit? Okay, so this is going to be probably one of your larger takeaways. Notebooks are fairly big in the data science world in terms of how they're used. And what a notebook is, well, sorry, I'll get into that. Sorry, I should back up a little bit. Just because I get very excited about notebooks, I want to tell you all right now because it's exciting. Oops. And then languages. So is there anybody not familiar with T-SQL in here? Okay, good. That's good. So T-SQL is the language we know and we're comfortable with. A few years ago, I was encouraging people to learn PowerShell. Is there many people in here using PowerShell right now? So when I gave a talk similar to this a few years ago, that was exactly the same. When I asked how many people were using notebooks, there was very few, whereas with PowerShell, there's quite a few of you, well over half, I would say, are now using at least some part of PowerShell to a certain degree. So the next PowerShell, as it were, is going to be the notebooks. And the reason for that is when automation was huge, PowerShell became huge. Now that data science and AI is huge, notebooks are going to become huge. But the nice thing about notebooks is they're a little bit simpler to learn. There's a lot of resources out there, and you'll see more side benefits, I think, in the work that you do. So within those languages, though, one of the reasons that notebooks are so popular is it gives us a lot more access to other languages. When in SQL Server 2016, we started with Polybase, we were able to integrate with R. So you were able to write some R code within Management Studio for SQL Server. Has anybody done that? Written any R code? Okay, so a few of you have, so you're aware of that. So other than using SQL Server Management Studio, Azure Data Studio now, if you're connecting to Azure or using anything within Azure and using the notebooks, it is lots easier to use other languages within the notebooks. So those notebooks and languages somewhat go together. So if you were to learn a new language, one of those languages, if your company is moving towards AI or data science, Python is probably a good language to just pick up a little bit of. And the demo I'm going to show you today is in Python. I will make that available to you, so you will have the notebook. You'll see all the information in it, and it's not unlike a PowerPoint deck for you to take a look at. And you'll be able to walk through it once you've set up your system and go through a sample demo. So communication. Communication is probably the most important thing to be able to understand. And usually when people communicate, the most important part of that is language. So when we talk from within an organization, we're all talking English, but sometimes that English doesn't sound like English because they'll throw out words like regression, or they'll throw out words like cognitive services, or any other data science related or machine learning related concepts. If we aren't understanding what those words mean, it's very difficult to have a conversation. So it's important to have a conversation with words that we both understand. So I encourage you to not necessarily expect your data scientists to learn how to be a DBA, but just learn a little bit of their lingo. We have sessions all of this week, as well as some definitions in the slides that I'm going to go through about how do we have those conversations. If we're talking about the same words and when they say something to us we understand, then we can have better conversations about how we actually get our work done, and there'll be less discrepancies and issues because we're not understanding each other. So I showed this specifically around communication in my last session, and the reason I brought this up again is because I get this question all the time. People don't understand what some of these words are and how they connect to each other. I had mentioned that I often think of AI more as a bit of a buzzword or a marketing term. So I talk about this slide in particular because people don't understand sort of the hierarchy or the flow of what relates to what. And we can better understand our data scientists and help them implement the models that they're writing and the algorithms that they're producing for us within the applications if we understand the words. So data science creates algorithms for machine learning to develop cognitive services for use in predictive analytics that we collectively call artificial intelligence. So that's a very specific and generic, at the same time specific but generic, sort of definition of how those pieces fit together, but it kind of gives you an idea of what that hierarchy is and what relates to what. But more importantly, communication comes down to some specific words. So we like the importance of these words in data science will help you be able to ask questions so that you can implement the models. One of the things that I'm going to show you shortly is the deployment of an actual model. And as you can imagine, anytime that you're doing a deployment, there's going to be questions that you're going to have. You're going to want to make sure that you have all the information and pieces of the solution that's to be implemented together. And sometimes that's going to mean having a conversation with your data scientist. And as much as we, as technologists, are used to being some of the smartest people in the room, it's important to remember to check your ego and your insecurities at the door when it comes to talking to data scientists. their language is different, and we just have to accept that. So sometimes think of it as somebody from a different country who's speaking a different language, and if they say a word that you are not familiar with, don't feel shy about asking them. They're just like us. They want you to succeed. They'll tell you what the answer is. If you don't understand a concept, or if you need additional information, they're going to be happy to share that with you. So a couple of these I wanted to go through because they're a little bit more common, and they'll be somewhat more related to what you're doing as a professional. So library is one that you may be familiar with from your days as a programmer, if you started out as a programmer or if you do any programming in your company. The library is a collection of functions and methods that allows you to perform an action without writing a lot of code. They're used fairly often in data science, and it's one of those things that you would typically ask for from one of your data scientists before you go to implement something. Do you have any additional libraries that you need? Where are those libraries located? How do I find them? Questions like that. So I started off with a simple one. Might be one that you already know. See, you guys are already data scientists. It's all going to be good. Then the next one is a model. So we talk about a machine learning model often, and it is basically a mathematical representation of a real world process. It'll allow you to generate a machine learning model and provide training data to machine learning algorithms, and it allows them to learn from it. So the models are what you will be implementing quite often for a solution, along with the algorithms. Let's move on to instead of me reading all of these out, I'm going to put it in just because of time. I want to get into the demo. I'm going to leave these in the slide deck, put it up on the PASS website so that you can refer back to it, so that I don't just sit here and define a whole bunch of terms for you, because I'm getting bored of it myself. So we'll move on. Azure Notebooks, Jupyter Notebooks, and Azure Data Studio. I put them all on one slide because they somewhat go together. Azure Data Studio is a tool provided by Microsoft. It's a free download. Updated monthly, gets updated regularly, allows you to code in different programming languages. If you haven't used it, I highly recommend it. It's more often used for connecting to Azure, obviously, because it's got Azure in the name. And it allows you to use notebooks within it. So Azure Notebooks has been created as a derivative of Jupyter Notebooks, which is commonly used for data science. It's a tool not unlike SSMS that will allow you to write code, but incorporates Markdown with it. I'll give you a bit of it. It's part of my demo, so I'll give you a better overview there with it. And it'll allow you to get descriptions as well as outputs within the same notebook or document. And then that can be saved for later. Just as a basic DBA tool, it's very handy outside of data science if you want to create any runbooks or processes for junior people to use, or if you have processes that you often repeat. So I know that there are a number of DBAs that will use a notebook in the development environment. They'll run through all of their tests before they move things to production, and then they'll run it in production and compare the results. Or one person will run it in the test, give the notebook to somebody else, they'll run it in production, and then be able to compare the results to make sure they get the same thing. Yep?
When you use the term notebook, are you talking more like a run book, like a series of code, or still not notebook?
Okay, so the question was, what exactly is a notebook? Is it like a run book? Is it a series of code? It's an IDE, so it's a graphical interface that you can use to write code. There may be a better way to describe it, but I prefer to show people things. So I'll show you in the demo what it actually looks like. You can run code in it, or you can just leave it with text. But to get the text, you can format the text using Markdown. I'll show you in the demo, and it'll make a little bit more sense. I'm definitely more of a visual person. integrations. So when doing data science, there's a lot of different pieces sometimes that go into what you need to do and produce and then output into production. So those integrations can come from different sources, and there are integrations that are available for that, and they're typically runtimes or other IDEs, workspaces, or data sets. So for Data Factory, there's a number of runtimes that can be used to integrate data, whether that's part of your model or whether that's part of your overall solution will be determined within your company as to how that gets resolved. So at some companies, it'll be the job of the data scientist to bundle everything up and give it to you in a nice, neat package. Unfortunately, that's not going to be the case for everybody. Sometimes you're going to have to make sure that you have all of those pieces. And that's why that communication is so important, is to determine what pieces your data scientist has and is going to give you to do the deployment versus what are the pieces that you need to acquire and integrate to deploy. There are DevOps for data science, and I highly encourage you to take a look at that. It is outside the scope of the demo today, but for larger deployments, it's definitely a process worth looking at to make those pieces easier to reference and to keep versioning to make sure that you're always deploying the correct versions. There are a number of different runtimes listed here. The PowerShell is sometimes used within the workspaces or just getting and pulling in different data sets. And that can be run within the notebooks so that we have everything in one contained space. And then using that to deploy web services is often quite handy. And then the general skills for Azure are those that are skills that most DBAs need, whether it's Power BI because you want to look at things after the fact. Again, all of these are dependent on your organization, or deployments themselves that you might want to do within the Azure Data Studio. The ARM templates are important to understand if you have any kind of sysadmin role within your organization, as well as your DBA role, if you have to deploy any servers when you go to deploy a new item to production. So those are all quite important. Just general things to think about if you think that your organization is going to need those for you to learn. There's a number of different languages that are important. Most of you seem to already have a good handle on PowerShell. A lot of the data science stuff is done on Linux. So if you haven't dabbled at least a little bit in the Linux world, you may want to look at that. There is, last year Bob Ward put out a new book of SQL Server on Linux. That might be a good place to start because it's not too much new information, but it gives you the ability to learn something new without learning something all net new. Because you already know SQL Server, translating that knowledge then to Linux makes that transition a little bit easier for your knowledge base. But when it comes to coding, there's a lot of data science coding that's done, whether it's Python, R, or Scala. And Python, from what I've seen in the industry, seems to be the more prevalent piece that would be related to an actual DBA role. So there's a lot of interesting and neat special commands that you can do with Python that is not dissimilar to things that you would maybe sometimes do not with PowerShell, but as the same concept of those periphery things that we need to know. There's a lot of file movement or automation that gets done with PowerShell, and with Python, there's a lot of commands that are useful when doing data science projects. So just having a small, I like to say it's almost a know enough to be dangerous kind of knowledge. That's kind of where you need to be at with something like that for a DBA. And then, of course, the overall Azure architecture. I like to bring this up because there's always so much more to learn. And depending on your organization, what pieces of those are going to be important to you is going to be hard to know. Data Factory might be hugely important for you as an organization that is going to bring data in so that your models can use them. So it may not be it may be part of your deployment where some of the pre-tasks are that data has to be brought in and cleansed or moved, or you need to run an ELT of some sort before the data can be used with your algorithms or your models. So just keeping in mind what some of those other pieces are for that overall architecture so that you can have proper discussions with your data science team. So this is a description, or a visual description, because of course I love pictures, of some of the things to operationalize models. Keeping in mind that a lot of this is done by the data scientist. So as much as this looks like a lot of work, over 90% of it is done in that first stage of preparing data. A lot of the work goes into preparing the data before the data scientist even gets into doing any sort of experiments, whether they're training models or testing them. But when it gets to the very last step of the deployment, where we're deploying a service to monitor that model, that's when the DBA typically gets involved. Usually because it touches data in an organization, if your sysadmin is not very keen on the data science aspect of things, because it is something that touches data, it usually falls to a DBA to actually do that deployment. So I'd like to call it more of a data engineer role than necessarily a DBA role. It often falls to us to do that operationalization and deploy the model to production. The data scientist is responsible for giving you everything that you're going to need to be able to do that, but it's important to be able to sit down with them, have that conversation about what it is that actually needs to be deployed and how they're going to do it. So then this is the more interesting part now. So we get into, okay, we're going to actually deploy this model. What is that going to look like? So the example I like to do is a single box model. We have a package. We want to take that package and be able to reference it on the web. So there's a number of different prerequisites that need to be installed, and I'm not going to go through all of that because it actually took me a fair amount of time to set up my system and get everything on my laptop ready to go to be able to deploy something. I do have scripts for that I will share with you so that you hopefully don't have to go through as many pains, but because we're limited on time, I'm not going to go through all the setup aspects of it. We're just going to look at the actual deployment piece. But those are the different packages that are needed for deployment, and I just reference them in my code to say that we have to have those. So the idea here is we're going to have a single node for the web, a single node for compute, and then we're going to have some storage. The storage will talk back and forth with the web and the compute node, and the web and compute node can be leveraged and scaled out. So this is just a very simple model, make it easier for learning, but as your demand grows or as your models grow, as you start doing more AI, you can definitely scale out all of those pieces. Is there any questions about the one server model? Yep, at the back.
Can you do all of that on premise, or does it have to be your cloud?
Oh, that's a great question. Does it all have to be on-premise or in Azure? You can do either. You can do either on-premise or you can do Azure. It's entirely up to you, and there's ways of doing it for both. So that's a good question. So I'm going to switch over now to my demo. So just give me a second here. Okay, so this is Azure Data Studio. This is a notebook in Azure Data Studio. So it gives me the option of choosing up here my kernel. So this I didn't change the kernel, but this week what has come out for Azure Data Studio also is a Python or a PowerShell kernel. It has just gone GA. It used to be only the Insider Edition. So you can natively write PowerShell in Azure Data Studio now, which is very exciting, because when you create something, when you write code, it will keep the output within that same block. So it's almost like a Word document is, I guess, how I usually, for some reason, think about it, as an actual Word document where I can have text, and then I can have my output, and then I can write some code, and then I can have my output, and then I can put some text in for reference and have some output. So you can either do SQL, oops. Sorry, I didn't want to change it. There's a number of different kernels to allow you to write different types of code within a notebook. So they are listed here. So you can just use it to write SQL code, which is originally how it all started. But you also have the option to do many different other things. So if you are familiar with R, you can also write R code in a notebook. These notebooks are contained within Azure Data Studio. You can save them off as a notebook file. So they all end in this IPYB file extension. You can open them in other utilities. When you upload them to GitHub, it renders them correctly. So it would look the same here on my desktop as it would in GitHub if you upload it. A lot of what the Microsoft education team and Anna's team is doing is providing workbooks and workshops within Azure Notebooks that you can just take and run and learn new exciting technology. So this actual comment here as deployment is just a text box that I used to make the font larger by formatting it with Markdown. Markdown is a way to, it's a derivative of HTML that allows you to format text and then make it look pretty, is really what it is. So it'll allow you to do different fonts, it'll allow you to create lists, and it'll allow you to include diagrams as well. I like this for giving to clients because they can then reuse that notebook and know before they run something what the output is expected to be. They can save it as a separate file and have two files just named differently, reference one that has the output of what they should be expecting, and then be able to reference that and know if that's the output they actually got. Even if I'm just running SQL code, it doesn't have to be anything fancy. And that's a little bit nicer than saving a text document for SSMS. It's a little bit more interactive that way. They can run things within the document and then see the output right away. So what this demo does is it gets things ready to deploy a web service. I'm going to deploy it as a Docker image, and I'm going to show you the results after I've run that so that you can see what actually happened when we ran a test of the system to see how it worked. So there's a couple of prerequisites I list in here to make sure that you have a few things entered and prerequisites set up to make sure things will work. One of the things that I found as more of a DBA that was a little bit confusing when I first started using some of these tools is a lot of them are open source. And as much as we complain about Microsoft not telling us what's new or what's changed, open source systems, I find, or utilities are notoriously terrible for that. And I'm forever trying to run something, and something is out of date because the versions don't work together. So one of the things I had put in here is when I'm importing some of these packages to make sure that I'm checking that the version is a version that's going to work with the rest of what I'm going to do in my demo, to make sure that I have the right things, because I've been burned by that more than once. So it's just kind of nice sometimes to check your versioning, make sure everything is up to date. Then a workspace is a concept of an area where you're keeping all of your information. So unlike, it's like if you're in Azure, you've used workspaces before to create a unit of work. So I'm going to create a workspace to download this model to my local directory where I'm going to run it to deploy it, because I want to do some testing on it. I'm envisioning this as something that was given to me by a data scientist. I don't know much about it. I want to see it. I want to play with it and work with it and see what happens. So before I test it, I want to make sure it's working on my local drive so I have the understanding of what it's going to look like when I actually deploy it to production. As a DBA, I've never deployed a script or an application without at least sort of smoke testing it first to make sure it's going to do what I expect it to do and it's not going to blow up on me. I actually did that once where I trusted the developer. It's like, oh yeah, I'm sure that script's going to work great. And I go to run it on production and it doesn't work. And then I think I've done something wrong. So I usually try to test it out, whether that's on my local system or a test system, before I actually run it. So I'm going to take that, I'm going to load some data. And I'm going to do a bit of a prediction test. So one of the things that this prediction test is that I did, I put this in here more for your understanding, because again, we're talking about communication and what makes sense. So I put in a little bit of information here that you can reference and come back to later. I don't have time to go through all of it to make sure we get through the demo. But we're going to look at, I put the information here on what exactly a classifier was, because when I came up with a classifier, I didn't know exactly what it was, but I wanted to have a concept of it from my data science professional who had given me this model to run so that I could have an output to look at to see how accurate the model was. One of the things that you want to be able to check is how is it different on the test system as it is in production. Quite often that's something that the data scientist will check for you, but sometimes you want to do a little bit more checking on your own. So this gave me the opportunity to check that. And what that matrix gave me was a bunch of different outputs. And because I don't like just looking at numbers and it didn't give me a real understanding of accuracy, and something that you may or may not be aware of is accuracy is typically rated between 0 and 1. So the fact that this has an accuracy of 0.91 is very high. But sometimes understanding that when we're not used to such small numbers, we're not, as data scientists, I think they were born counting decimals and not actual numbers, whole numbers. But for me, a whole number means a lot more, or even a visual is a little bit better. So I found this utility that would map it for me, and I put it in. I put it into a pretty diagram so that I could see a better idea here about how accurate this was, and the closer that we were to get to 1. So the darker squares are much more accurate than the lighter squares. So you want to see how dark you can make your map. So I was fairly confident that this was a fairly good model, that it would be well deployed, that I wouldn't have any issues. I had done some testing of it. So I wanted to deploy it as a web service in a container, that being the easiest way to do that. So there's a lot of code that, I guess not a huge amount of code. I'm not going to go through the details of the Python script. That's something that you can take away. I will upload the Python scripts, the notebook with the Python scripts so that you can go back and reference this and run through it yourself. And yes, I will give you my contact information so that you can contact me with questions. Because inevitably something will go wrong. It just seems to be the way it is. So I was able to run that through to create my environment file. And then once I reviewed that environment file, there's a number of different things that you have to make sure that you have in place. So I have a few comments in here to tell you about those. we're going to need a configuration file. I know I'm going through this very quickly, but there's a lot of detail in the notebook to tell you what the different pieces are that you're going to need to be able to deploy this. And basically what this is saying is to be able to deploy this web service, I need a certain number of cores. This is very, very small. These details you should be able to get from your data scientist. They will have done all of this testing. They should know, or they'll ask you to work through with them to determine how many cores is this machine going to use, or how much to be able to run this prediction correctly, how many gigabytes of data are you going to need, what kind of memory is going to be needed. And then you can deploy it as a container. This takes a little bit longer. So I had pre-run it so that you could see the finished process. It can take up to 8 minutes. And then I get it to print out for me at the very end here a connection string so that I can connect to that. So I can take a look at what it actually did, take a look at the model that's been deployed, and actually do some tests on it to see how it did. So this particular model that I deployed would take in information of numbers, and it would predict what that number was. And then because it's difficult in black and white to be able to tell which ones are correct and which ones are not, I had written a bit of Python here to take a look at the results and tell me which ones were correct and which ones were not, and label the ones that were not correct as red. So that kind of gives you an idea of how well that model was able to predict those results. I had done this in my lab before I put it out to production, and then I can compare the two at the end to see how that was produced. So you can see that in some cases, depending on your organization, you're going to need a little bit more or a little bit less of the Python knowledge, depending on how far your role goes. So keep in mind your individual organization and how much you're going to be expected to do of the data science aspects of your job versus somebody else. And as long as your communication is good and you guys cover all the different pieces, it really doesn't matter necessarily who does which, depending on your interest levels. But making sure that all the pieces are covered and making sure that if you're going to then scale this out, so I created this so that you would have something to practice on, so that you would have a couple of notebooks to go to just practice deploying models on your own machine or even on your laptop, just to play around with it, to get some comfort level with it. And then the next stage of your learning from there would be to go back and look at some of the DevOps for machine learning. And if you're going to be scaling out to larger nodes and more compute power, you're going to want to make sure that you've got some really good processes and procedures in place. If you aren't already doing AI, now's the time to get good processes and procedures around your DevOps for data science. Yep? Yes, you can. So the question was, can you switch between languages within a single notebook? And you can. That can be done within a single notebook, yes. You can also, I had showed a single picture.
Can you demonstrate that? Because I thought that could be done. Like once you select the kernel, that's for the entire notebook.
It is, but you can call from that kernel, you can call another one. Okay. So it's not native to that extent, but you can call one kernel from another kernel. I can't remember the command off the top of my head, I'm sorry. That's not something I normally do. I usually keep my notebooks separate because, just a sec, the tasks that I do are typically very different in SQL than I do in Python and I do in PowerShell. So but you can call one notebook from another. So you can put them in series. I've done that before, where you have a link from one notebook to the next notebook. So you can continue on and have a series of notebooks. Yep.
You deployed a model. Is this model visible for a person after 15 days or 30 days? Or do you have to just remember in my mind's eye that there was a model I deployed 15 days back? This is what it is doing.
Do you mean this demo specifically or in general?
In general, when we talk about these
It's kind of like deploying an application or a package. So the question was, what happens to the model after 15 days? How do I find it? Where is it? At the bottom of the script, you'll see the connection string. Usually that gets embedded into an application, and it's called typically from an application that way. So you would have reference to it when you do it, and you can customize all of that. So all of those bits and pieces can be customized. I just didn't go into that depth in the demo because of time. Yep.
So just kind of follow on that. So you would see it out there because you would have that deployed container in your Kubernetes environment or your Docker environment. You would see that out there as a node.
Yeah. So in terms of the hardware, yes, you would see that as the node, but the actual address of the model might, I think that might have been that's what I was referencing anyway. But yeah, the container would be out there. You would have that in your infrastructure as well. Yep.
Coming to this notebook, if you have a T-SQL code and if you want to run it for deployment, does it actually connect to the database? Did you mention all the connection strings?
Yeah. So the question was for the notebook, and if it's T-SQL, does it connect to the database? Yes. What would pop up? So demos on the fly are usually not recommended, but we'll see what we can do here. New notebook. So it comes up as a default of SQL. So if I code and I put, uh-oh. Now I got to remember a database name. I'm not connected, so it's not going to come up. If I try to run this, it should basically come up with my connection string to be able to fit in. And then whether that's my local connection string or something in Azure, you can connect to your connection string, and then it'll run the query for you. And it'll produce the output in the same way that it did in my notebook here. So this top piece here is text. This piece here is the code. And then this little piece here is sort of like that message that you would normally get in T-SQL. And you would get that just within your notebook. So if you have a table, you'll see your table output right in the notebook. Yep.
Is the code and the metadata for connections and stuff, is that stored all in one place? Or
For the Azure Data Studio?
like for what you were just doing there, for instance, you were doing a SQL thing and then you had to put metadata to the connection string. Is that all contained in a single unit, or is it stored in different spots?
I don't think the connection information is.
Where is the connection? So basically, where is the connection information stored in Azure Data Studio?
Yeah.
I don't know. I will be honest on that one. I don't know where they store it. It's like Management Studio. It's a tool that I use that I didn't actually think about that aspect of it. I apologize. Vicky Harp would know. Yep.
And then I guess this is deployed to the destination where Azure Workspace. Wow.
I had actually just deployed this to my own Azure subscription. Is where I had deployed it.
I guess my question is, we're trying to implement this, but we're an on-prem shop.
So there's still a lot of things that you can do on-prem. So you can deploy this on-prem. I didn't because I have an Azure subscription, but yeah, you can definitely do that as well. Yep. At the back.
So you said it takes 8 minutes to deploy that, right? So you have to do that on a bigger database. How do I estimate that time?
So the question was, how do I estimate the time it takes to deploy a model? And I would determine that based on how long it takes in your test system is usually a good indicator, and then adjust for hardware. I'm not sure that there's a more specific way to determine that length of time. Would you have an answer to that, Anna? Not to put you on the spot, but.
If you're going into the Azure container instance, it should be pretty much the same model, because it will be very small.
Yeah.
Was
Yeah.
there specific-
So 8 minutes is usually kind of long for that. Yep.
Was there a specific container image you used?
No. So the question was there a specific container image I used? No. I just used a very, very small one so that, because I didn't need it for a very long period of time. Yeah. At the back?
Yeah, I mean, we're DBAs, right? I kind of go through things before. It's kind of really dial up things. In your experience, what do you think DBA can bring more value in this whole process?
I'm sorry, could you repeat the question?
I mean, in your experience as a DBA, what makes us different? What do you think we can bring more value in this whole process?
So as a DBA, where can you bring value to the process?
Yeah.
I think communication, learning notebooks, and maybe a little bit of Python. I think the importance is the communication and making sure you work together as a team. Because I've seen too often where DBAs and sysadmins don't get along. And then there's issues with hardware. If you start the process of working together as a team, everybody's going to succeed. So that's why communication was the first thing I spoke about, because I think that is the most important piece. And learning their language, whether that's the language of notebooks or whether that's the language of Python, the easier it'll be to be able to create that communication and reduce the gap. So I think everybody will get more out of it if there is more collaboration. Does that answer your question? No? If you want a technical answer, learn Python.
I guess the question really is, maybe, I can think about it, I can ask someone else to do the whole thing, right? They're not how to ask DBA. They could ask me, they could ask anybody who has knowledge doing those things. What exactly is the DBA role here? AI.
So I think it's important for DBAs to know a bit about AI, mainly because you guys know the data better than anybody else. Ultimately, the AI story is a data story, and nobody in your company should know your data better than you do. It's true. Well,
As your application DBA, I mean, if you're a true application DBA, you probably have a lot of business data than others. But if you do have a dedicated BI team,
yeah.
they have much better understanding than us.
Then the DBA that works with the BI team is the DBA that's probably going to do a lot of this. And like I said at the beginning, it definitely, your mileage will vary because it depends on the size of your organization and the different roles within that and how you segregate that. Some companies, DBAs do a lot. Some companies, they do nothing but monitoring tools. Depends on the size of the organization.